You ever wonder how all your devices just talk to each other? I mean, from your office network to the entire internet, there's this invisible architecture, right? A hidden shape that makes all that connection happen. So let's pull back the curtain and take a look at the secret blueprints of our digital world.
All right, here's the game plan. We're going to start with the absolute basics. What even is a network? Then we'll get into the blueprints that give them their shape. We'll look at the 3 foundational designs, peek at some more advanced setups, and finally, wrap up with why any of this still matters in today's wireless world. Okay, so first things first. Before we can start talking about all these cool shapes and layouts, we've got to make sure we're on the same page about what we're actually, shaping.
At its very core, it's really this simple. A network is just 2 or more computers hooked up to share stuff. That's it. Could be a file, a printer, or your internet connection. The whole point is just getting everyone connected and sharing resources.
Now this is where things start to get really interesting, because connecting all these devices, it's not just a random free-for-all where you plug cables in wherever. No, it's a deliberate, planned-out process. It really is all about the layout. So that leads to the big question, right? How are these computers actually arranged? Is it just chaos, or is there a master plan? Well, if you guess there's a plan, you are absolutely correct, and that plan has a name.
And that name is network topology. It's the map, the schematic, the blueprint that lays out how all the nodes, which is just a fancy word for any device on the network, are connected to each other. It's the architecture of the network.
Now these blueprints can get super complex, but here's the secret. Most of them are just built from a few simple, fundamental designs. So let's break down the 3 basic shapes that are the foundation for pretty much all network design. First up, we've got the bus topology. This is the simplest of them all. The easiest way to picture it, think of a single main street and all the houses, or in this case computers, are connected directly to it. So how does it work? Well, it's incredibly simple. Every single device connects to one main cable, which is sometimes called the backbone. Then, to stop the signals from literally bouncing off the ends of the wire and causing chaos, they stick a little thing called a terminator at each end. That's it. Simple, linear, and straight to the point.
And this design is a classic trade-off. The good news? It's super cheap, it's easy to set up, and you don't need a lot of cable. But the bad news? Well, there are some big limitations. That main cable can only be so long, and that means you can only connect so many devices. So yeah, it was great for small, quick setups, but it just doesn't scale up at all.
Okay, before we get to our next shape, we need to talk about a really important concept, the token. Imagine you've got a group of people in a circle, and there's only one ticket being passed around. Only the person holding that ticket is allowed to talk. In networking, that ticket is a special little packet of data, and it's the key to keeping things orderly in our next design.
Which brings us to the ring topology. And yeah, as the name suggests, this one connects everything in a big circle. Think less of a straight road and more of a traffic roundabout.
So in a ring, every device is connected to exactly 2 others, forming this perfect closed loop. And that token we just talked about, it's constantly flying around the ring in one direction. If your computer wants to send something, it has to wait, grab the token as it passes by, attach its message, and send it on its way. This is actually a really clever system because it prevents data collisions since only one device can talk at a time. This design really shows off its biggest strength and its Achilles heel. On the one hand, it's incredibly orderly. It can handle a lot of traffic really well because there are no collisions. But, and this is a huge but, if just one computer or one cable in that ring fails, the whole loop is broken. The entire network goes down. Ouch. All right, our third and final basic shape is the one you're probably most familiar with, even if you don't realize it, the star topology. And the best way to think about this one? An airport hub, where all the flights have to go through one central point to get anywhere. In a star network, none of the computers talk to each other directly. Instead, every single device gets its own dedicated cable that connects it to a central device, like a hub or a switch. This central box is the brain of the whole operation. It's the traffic cop. It manages everything, taking data from one device and sending it exactly where it needs to go.
The pros here are massive, and it's why Star totally took over for local networks. If your computer's cable gets unplugged, who cares? It doesn't affect anyone else. This makes it super reliable and way easier to troubleshoot. The only real downside is that everything, and I mean everything, depends on that central hub. If that box dies, the whole network is toast. But as hubs got cheaper and cheaper, this reliable design just became the go-to standard.
So there you have it, our 3 main building blocks, bus, ring, and star. But of course, we didn't stop there. We started combining and expanding on these basic ideas to create much more complex, much more powerful network designs.
Let's start with the most ambitious design of all, the mesh topology. The big idea here is all about maximum reliability through maximum connection. In a full mesh network, every single device is connected directly to every other device.
And just to give you an idea of how wild that is, look at this number. To fully connect just 10, only 10, devices in a mesh network, you would need 45 separate cables. The cost and the complexity are just staggering, but the payoff is a network that's almost impossible to take down.
So why on earth would you go through all that trouble? Well, this quote really sums it up perfectly. With dedicated point-to-point links between every single device, you never have a traffic jam. If one path fails or gets blocked, your data just instantly finds another way to get there. This is the kind of design that powers the backbone of the internet, where uptime is absolutely critical. You can really see a clear evolution here, right? We went from the simple and cheap bus to the much more robust star. And from there, things got even smarter. A tree topology, for instance, just takes the star idea and builds on it, linking multiple star networks together. Think of an office with a star network for each department, all connecting back to a main backbone. And then you have hybrid topologies, where you just mix and match, maybe a star backbone with a bus network for one specific area, to get the best of all worlds.
Now, I know what you might be thinking. This is all cool for a world full of cables, but I use Wi-Fi. What does this have to do with me? Well, believe it or not, even in our wireless world, these logical shapes are still very, very much alive.
So I'm going to leave you with this final thought. Think about your Wi-Fi at home. All your devices, your phone, your laptop, your TV, they all connect to one central box, right? Your router. There might not be any physical cables you can see, but that logical blueprint is still there. So, which of these shapes do you think your wireless world is secretly built on?